Hello, Stat 300. This is Professor Gonzalez, and I'd like to do some homework problems. HW 4.2 from the assignment side of Alex. And here we have just two questions that I'm going to show you more of 4.1 and 4.2 on the next video that does the adaptive side of Alex. But with these just two questions, there's just two of the repetitive same questions basically. And given these five pieces of information, x bar, s sub x, y bar, y sub, s sub y rather, and r, can you come up with the least squares regression line? So now that formula for the least squares regression line, let me write it right here. Well, I think I want to start by saying, remember from algebra, y equals mx plus b. Right, and when you saw that, remember that this b value is our y-intercept, and our our m value is the slope. And these are linear equations, so when we graph them many times in algebra, you would plot the y-intercept, which is the b value, and then you would step the slope out up 3 and over 2 or whatever the slope was, and you could make an equation of the line. Now this is a least squares regression line, which is a linear equation, so it has a y-intercept and slope, but it's using all the scatter plot points in statistics to come up with a linear line that fits that scatter plot to the best of our ability, using a process of least squares regression. Okay, so this information is given to us. So some of the formulas that you need to know would be the least squares regression line formula. And so whenever we're talking about, whenever we're talking about the least squares regression line, which is a predictive line, right? It's not the actual data. The actual data would be the scatter plot. Here, let me just do something down here. Even though this is to come, this is what's coming up. Basically what's going on here is you've got these data points that we're gonna, that are graphed. And if the data points show some kind of correlation, like this one shows a positive correlation, then what we try to do is we try to make a line. I probably shouldn't use that highlighter. We try to make a line that fits this data to the best we can. Now we can just eyeball it right now, right? Something like that. And I could move this around, I think. Oh no, I can't move it around. Anyways, this line is called y hat, and it's a predictive line, right? Because if I wanted to find out what's going on in my data, like right there, whatever that is, I can go up and I can actually see in this case, oh, there's the point right there. So in that case, my predictive line is off by a bit, right? Quite a bit. But I also want that line to represent this data point down here. So when I put this, the actual value of this is over here, but my predictive line would tell me about there. So this is a prediction. This y hat gives us a prediction. To the best of our ability by making this y hat, which is the least squares regression line. So right now we're trying to come up with this line right here, this least squares regression line. It is a predictive line. It's not the exact data, right? The exact data would be these plotted points. It just gets us close, and it helps us see that there's a positive correlation. In other words, the more this happens, the more we go this way on the x-axis, the higher the y-axis also goes, right? So we're here, and the y is here. We go out here, now the y is up there. So I'll talk more about this in the next video. But right now, I just want to see, can we come up, that didn't erase from it. Can we come up with the least squares regression line given those 5 pieces of information, the 5 data points, or not data points, 5 pieces of information. So the reason why I showed you this slope formula up here from algebra is just because there's definitely some connection between the two. Y hat is a linear equation, which so is y equals mx plus b. And I'm going to use green because our y-intercept is going to be written first, and it's called b sub 0. So that is the y-intercept. And then next comes our slope, which is called b sub 1. And that's the slope. And so that's x, and that's plus. So there's our regression line, and the red b sub 1 acts just like my m slope from algebra, and my green b sub 0 acts just like my y-intercept in algebra. You need a little bit more information, though. You still need to know how to figure out what b sub 0 is. So b sub 0 is found by taking y bar minus b sub 1 times x bar. And b sub 1 can be found by taking the r value and multiplying it by s sub y over s sub x. And with those basic formulas, you can come up with the whole, you come up with the y hat. So the very first thing we really need to get is b sub 1. And the reason why we need to do b sub 1 first, and if you don't, you'll find out pretty quick, oh, wait a minute, I need b sub 1 in that formula. So I better start with b sub 1 very first thing. So b sub 1 is found, once again, by taking the r value. There's my r value right there. So that is 0.30. And it says multiplying it by what? S sub y over s sub x. So s sub y is 1.9 over s sub x is 1.3. Let's go ahead and get rid of some of this, just because I think I'm going to run out of space. And then when I divide 1.9 divided by 1.3, and then multiply it by 0.3, I get approximately, and it's asking us to round to 4 decimal places. So I'm going to make this red since it's my b sub 1. I get approximately 0.438. 4385, because we want to go to 4 decimal places. Okay, then I need my b sub 0, which is my y-intercept, so I can find that also. B sub 0, if I take a look at my formula, and by the way, even if you're taking the in-class version of this, you're allowed to have, stats is the only math class you're allowed to have a formula sheet given by the professor during the test. So I will put a formula sheet up in Canvas that you could download and take a look at that has a lot of these formulas on it. And that is allowed on a test. B sub 0, when I multiply, well, what is b sub 0? B sub 0 is y, so here it is, right? Whoops, I just erased. B sub 0 is y hat, right there. So what's y hat? Not y hat, y bar. Oof, I got a headache right now, and I'm got to concentrate, even though this is a short video. This one should be easy. So we've got y hat. I'm going to put y hat in. The next thing is minus b sub 1. Well, I found out my b sub 1 on my last problem that I just did right there. So that's 0.4385. And then the rest of the formula says to do what? Multiply b sub 1 times x bar. X bar is right there, which is 12.8. So now when I multiply 0.4385 times 12.8, I get 5, it keeps on switching on me, 5.6128. So we got 44,000 minus that quantity, and so we do the subtraction problem. I'm going to write my final answer in green since my b sub 0s are always green, at least in this demonstration. And I get 43,994 and 3872. So now I have all the parts that I need, right? I've got my b sub 0, and I've got my b sub 1. And those are the pieces I need for this regression line. So here it is. The regression line formula is right here. So it's just going to be y hat equals, and I'll use some color just to highlight where I'm good and getting here. My b sub 0, which is 43,994 and 3872. I'm going to need to add that to b sub 1. We figured out b sub 1 way at the beginning here at 0.4385. And that b sub 1 is multiplied by x. So b sub 1 is the slope. And there's the equation for the least squares regression line. Let's do it again just to make sure we have this down. And once again, let's see, space-wise, I think I'm going to write my least squares regression line up here just to kind of try to drill it home for us. Remember, the y-intercept is called b sub 0. Remember, the slope is called b sub 1. And we add those two together, and that b sub 1 gets multiplied by x. So the first thing we want to try to do is try to figure out what b sub 1 is. So b sub 1 equals r times s sub y over s sub x. So let's put in those values. R happens to be 0.4. S sub y is 101. S sub x is 21,000. Divide that, multiply by 0.4, and we get our b sub 1. So our b sub 1, and it says round to 4 decimal places, so it's approximately going to be equal to 0.0019. I'm going to put the circle around that just because we have to refer back to that. Next, we're going to want to get our b sub 0. Remember, b sub 0, the formula is y bar minus b sub 1 times x bar. So b sub 0, we have to grab y bar. Y bar is 103. Minus b sub 1, well, b sub 1 is the value we got before. Where was it? It's right here, right above. So b sub 1 is just 0.0019. That gets multiplied by, x bar. So we go to x bar is, which is 8.8. So we do the multiplication, 0.0019 times 8.8, and we get 0.0167. And so it turns out when we do that subtraction problem, we get our b sub 0. B sub 0 is 102.9833. I'm going to put a circle around that. Those are the two pieces I need to make my least squares regression line, or also known as just regression line. And so that's going to be y hat equals my y-intercept, which is b sub 0, 102.9833. I'm going to say plus, let's say plus, and then my x. So plus, then my b sub 1 value, which once again is right there, which is 0.0019 times x. So there's my answer. Okay, so we've got more to do with this, but this particular 2 questions on the homework was just made just to see if you can take these 5 points and calculate the least squares regression line. Okay, hope that helped out. Take care. Bye.